thank you again, Kim, for having me up here in Queensland, and very excited to be able to talk a little bit about the Australian curriculum and what we've tried to do with the Cambridge resources for the next editions. Now, as you can see from my background slide, I've tried to capture some of the newer elements of the Australian curriculum, with the main ones being statistical investigations, technology and algorithms is in the new Australian curriculum, and they're really the main ones that have been captured inside that diagram. Other words that come into the new Australian curriculum, if you've read some documentation, you would have seen the First Nations people's elaborations in the mathematics curriculum. The word modelling seems to appear more than 100 times in the new Australian curriculum, and Queensland's certainly well set up for that, so that's fantastic. The new optional pathways at Year 10 replacing the 10A curriculum, and a number of new content descriptors as well. So good to talk about those things in this workshop today. So structurally, the first thing to note perhaps is the 6 strands that were grouped into 3, number and algebra, measurement, geometry, probability and statistics, is now 6 separate strands, with the geometry being replaced with the word space. So that, from a structural point of view, that's probably not going to make a huge amount of change to your courses. And you might remember from the previous version of the Australian curriculum, we had sub-strands as well, but those have also gone. So this is an image from the 8.4 Australian curriculum with the strands number and algebra, and then the sub-strands with all the elaborations grouped into those sub-strands like that. But now we just have the content descriptors just grouped into the 6 major strands without those subgroups. So this is just a snip from the new Australian curriculum. You can see the strand number, the content descriptor on the left, and the elaborations on the right. It's probably worth noting that an elaboration is a great suggestion of what that content descriptor might be about. But it's not necessarily comprehensive, not a comprehensive list of the content, and it's not necessarily compulsory either. So a great course in a school may indeed touch on all the elaborations, but a course might cover many other things as well. Okay, so what's changed in the Australian curriculum? Well, obviously there are some descriptor modifications and some refined elaborations with more of an emphasis, obviously, on investigation and modelling, technology and algorithms, and First Nations perspectives. That seems to be very clear. In Year 7, this is a list of the brand new content descriptors that didn't really have a content descriptor relating to it in the previous version. So place value with expanded notation, formulas, volume of triangular prisms is new, introduction to circles, pi and circumference has moved from Year 8 into Year 7. There's more about statistics and probability, and there's a couple of elaborations right through 7 to 10 dealing with algorithms, which we'll talk about more in detail later. In Year 8, here's the list of the new content, many of which you probably were doing in Year 8 before. I mean, most of our courses had financial applications. We were doing some form of linear modelling when we were doing some straight line graphs. Many schools were doing Pythagoras in Year 8 as extension. So these new descriptors don't always mean that you have to find 3 more weeks in the school course, and at Cambridge we found that too, where we didn't need to be writing tens of sections in a book for a year level, because we were covering those things anyway. There's quite a few in Year 9, but many of those things you would have covered. Rational numbers, introduction to surds, pi and so on in measurement. Some basic work with expanding and factorising is in all good Year 9 courses, but it is now more explicit in the Australian curriculum that would do more of that at Year 9. Year 10's a little bit different. There's some new content there. There's an emphasis on the accumulation of errors in measurement calculations. Exponential relations and equations used to be in 10A, but is now in the core. There's more on technology and graphing, and introduction to logarithmic scales is now in the core course for Year 10. There are a number of elaborations mentioning the word modelling. Networks or graph theory is a significant addition in Year 10, and Cambridge have 4 new sections added to the geometry chapter in Year 10 to cover that content, as well as some descriptors on statistical investigations. Now, some of the 10A content has been deleted from the Australian curriculum. Sine, cosine and area rules in trigonometry. Measurement for pyramids, cones and spheres is not listed currently. Graphs of circles and hyperbolas. All the work on polynomials is no longer listed in the new Australian curriculum. But some of the other 10A has carried forward. All the other 10A has been carried forward into the optional material. Also added to the optional that wasn't there before is solving simple trig equations and combinatorics, arrangements, selections and applications to probability, which has meant that 4 new sections are added to the probability chapter for Year 10 in the Essential series. One document you might like to get a hand on is Australian Curriculum Comparative Information document. And this one looks like this, where the old 8.4 Australian curriculum is on the right and the new Australian curriculum is on the left. So if you do want a snapshot of what's in and what's out, this is a very nice document to have a look at. Just download it from the Australian Curriculum website. Now, as I mentioned, the word algorithm is referred to 26 times if you do a search on the Word document in the Australian curriculum. There were 87 references to modelling and 30 references to the words First Nation, just to give you an idea of some of the directions that the curriculum is taking. So, how did Cambridge respond to some of these changes? Well, first of all, we did not want to throw away some of the popular elements and useful and successful elements of the Cambridge series. So we have kept our proficiency strand groupings and have maintained an exercise structure which begins with the building understanding questions attached to the preliminary activities and so on inside the section introduction. That might sit beside the lesson starter and the worked examples and the key ideas, for example. And those questions have been refined so that they might work as a class discussion rather than an exercise for the teacher and the students to work with. Then the start of the exercise is going to start with the fluency questions, and those questions that link directly with the worked examples and are fairly straightforward, and they cover all the key skills that we believe are important in that section. And then we have retained the problem solving and the reasoning and the enrichment groupings in every single exercise right through, in such a way that there's a grading of difficulty through each section, so that even if students are quite weak in mathematics, they still have the opportunity to tackle that first or second problem-solving question or the first reasoning question and a large number of fluency questions, so they still touch the curriculum covering all the proficiency strands in mathematics. The pathways through each exercise has been refined and retained in the next editions, and these types of documents will be retained as well, where teachers can use these lesson planners, if you like, with the 3 differentiated work programs being presented as 3 columns here. One's called Foundation, the middle one's called Standard, and the third one is called Advanced, where the foundation column sets all the building understanding and a large portion of the fluency with the easy problem solving and reasoning, and the advanced column on the other side has a much lighter selection of fluency and the more challenging problem solving, reasoning and the enrichment questions as well. You can see what I've done with that document. I've downloaded that from the teacher resources, and I've added my school's logo and some details regarding our assessment. And because it's a Word document, we would manipulate these before starting the course and use this as a bit of a planning document for our students. So for our advanced classes, we might delete a row, we might combine 2A and B and reorder some of those questions, for example. Another key feature we're going to retain, of course, is the progress quizzes, situated about halfway through the chapter, through the topic. And these are a great tool, of course, for formative assessment, for helping students structure their work across the topic and to be assessed halfway through. They are available in the text. They are available as a printable worksheet. Is that right, Scott?
Yeah, that's right. I'll also say that what is shown here is only the first question, but as David was saying, the progress quiz is about halfway to 2/3 of the way through a chapter and covers that amount of content before moving on to the rest of the lessons. But and that's how it can be done in place. You go through sections and exercises A through to F, say, and then get to the progress quiz. But there are other uses of these. For example, some schools might prefer to do, sections A and B, and then or A, B, and C, and then take a look at the do some progress quiz questions just of that. The first half of the progress quiz, say, and then do the second half, and then move on to the rest of the content, and then get to the review material at the end of the chapter.
At our school, students use it as a revision tool for the Trinity quiz because it does provide a decent summary of really all those sections coming before it. I believe it's also available in a digital format, which is auto-marked.
Yep, that's right.
If teachers would like to set that and just have the marks entered into the database.
Yep, so a quiz version, a worksheet version with space to print it out, and students will have working out space to do it by hand, and then there's just the print book and the PDF version as well.
Yep. Another feature we're going to retain are the problem solving and applications questions, situated about 2/3 or 3/4 of the way through a unit of work. And the goal there was to have some two or three extended response style questions where students could build their problem solving skills, deal with application questions before they do, say, a test at the end of the topic, where they might very well see a similar type of question, an extended response or application question in a test. So I think it's 3 questions per chapter actually there as well. Another thing we're going to retain that was new in the last editions are our list of learning intentions, which help to link each section to the curriculum documents. They may help teachers plan and lay out their lessons as well, and to help link the skills and knowledge of that section to the success criteria at the end of the unit, which is of course another feature which we will retain and refine for the new series. And these are written to provide a strong connection to the section examples and a new diagnostic tool, which we'll talk about soon. By the way, one new feature is that these success criteria, the answers, are now available and will be printed into the textbook as well, because each success criteria has an example attached to it.
And this will also be able to be printed as well, with checkboxes that can be physically ticked off.
Great.
Yep.
Another feature that was very much inspired by the Queensland curriculum documentation in the previous round And with the help of our Queensland author, Jenny Vaughan, we created a modelling activity for each unit of work. And you can see with these modelling activities, we have tried to come up with a context where students would do a preliminary task and then a modelling task followed by perhaps extension questions. The language used is the same as what Queensland had put together a few years ago for modelling, and that is that students would first formulate, then solve, evaluate and verify, and then communicate. Now, I know you can't read that from where you are, but I did want to show you a full example of a modelling activity. This one is for Year 7, and I won't go into it in detail, but it's dealing with some data associated with the amount of water in a dam and the capacity of that dam, and at what levels certain restrictions might apply if water restrictions are going to come in. So students start off with a preliminary task, just looking at some of the data. They work out the mean and the median and the range, and they answer some very simple questions associated with the data that's been provided. But in the modelling task, they are to write down all the relevant information that's been provided, and then to solve, they would describe the general trend in the data. They would work out differences and percentages from one month to another month about what's happening with the water level in the dam, and they would solve a number of problems associated with the differences between the different water levels. And then to evaluate and verify, they would use this data to determine the month for when something would apply, like a certain water level restriction. And then from that, they would make estimations and then finish by summarising this data in a short report. And so that was the structure that we used for the modelling tasks. And this is a slightly shorter looking example for Year 10, where students were to model the situation where someone was going to extend a house, for example, with a veranda of X width, with a preliminary task where students are just playing around with a couple of numbers and exploring the area of the house and the veranda. Then to formulate, they would need to set up an expression for the area of the veranda. For solving, they would use that expression to explore different values of X and different values of the area, and also explore which values gave integer values for the width and the area, and thinking a little bit about what values of X produced areas which weren't integers, and vice versa, and so on and so forth. So these are the types of things that we have at the end of each chapter. We also have an investigation at the end of each unit, but these are the types of features that we wanted to keep in the new series. Other things that we're going to keep are the Now You Try examples that are listed below every other example in the textbook. So you'd be aware that there's an example with work solution and video available, but attached to every one of those underneath there's a very similar example called a Now You Try. So if teachers were using the first example as a board example or in a flipped learning classroom, there's always that second one where you could engage student activity and try to make sure students knew what you were talking about in the previous example. So those Now You Tries are going to be there as well.
Yeah, that's right, and it adds a level of more active responses to what the idea of a worked example, rather than passively reading through the solution that is given, or even watching someone in the video do a demonstration of how to solve the question presented in the example. It is then to immediately do an identical type of question before getting to the exercise questions.
Yeah. And the answers to the Now You Try are also there for them to look up if they're doing them on their own. All right, moving on to technology and algorithmic thinking. We were slightly inspired by some of the work done in Victoria, and there will be a digital chapter available called Algorithmic Thinking. and this will be part of the text. And each one of those chapters deals with the different content and also tries to address the New Australian Curriculum content descriptors. Now, we won't have time to do a workshop fully on just algorithms, but one might say that in mathematics and computer science, an algorithm is a finite sequence of rigorous instructions typically used to solve a class of specific problems or to perform a computation. So obviously with that, if we're thinking a little bit about the way the world's going and where the problem solving is these days, this is an area that seems to be seeping into the mathematics curriculum and not just into the computer science curriculum. We could be finding the shortest path through a network. We could be trying to solve problems with timetables. We could be trying to solve an equation we can't solve algebraically. Or we could be constructing an object via a specific algorithm. We could be simulating. And in fact, the word simulation comes up quite a lot in the New Australian Curriculum. Or we could be solving maximisation and minimisation problems using algorithms because calculus is not available or might be too complex. Or we might be searching and sorting as algorithms do these days. So with algorithms, we are adding a chapter called Algorithmic Thinking to the digital, and we're also adding a special investigation for each unit of work, which is separate to this chapter. And I'll mention those briefly now. So in Year 7, we have 3 activities, one for number and algebra, one for measurement and geometry, and one for probability and statistics. The snip I've chosen there, you can see, relates to turtle graphics. Some people might have used that before, where students use very simple code and repetition to create patterns. In Year 8, we have 3 activities, one for divisibility tests, testing for divisibility using flowcharts. There's an activity for maximising and minimising rectangular areas, and there's also sorting data using very simple pseudocode in probability and statistics. In Year 9, a similar setup, and also in Year 10. There are 3 activities there as well. For the chapter of algorithmic thinking. But we decided that we wanted a little bit more than that, and with the Australian curriculum descriptors, we felt that we wanted something very accessible, using technology that everyone had available to them, like Excel or dynamic geometry. And we decided that we would write one algorithmic thinking activity called Technology and Algorithms activity for each unit of work. Most of them cover the content descriptors, but there are other activities that relate more closely to the units at hand. Now, these structures are a little bit like the modelling, with a getting started or preliminary activity, followed by another section where students are applying an algorithm in some way. It could be just following a series of instructions repeatedly, or it could be flowing through a flowchart, or it could be building a geometric construction following a set of rules, which I think is the gist of the content descriptors in the Australian curriculum. Each activity uses technology. Spreadsheets is a very popular one for applying algorithms. Dynamic geometry, graphing calculators were the main technologies used in these activities. And each activity also has an extension where students might adjust parameters, look into a problem in more depth, or they might build more complex algorithms to tackle more challenging problems. Here's a quick example of one. The first one is Year 7, Soccer in the Rain, where students have realised that over the last 100 matches, 20 of them were cancelled due to rain. So in this activity, students are simulating the chance that it's going to rain, which is 1 in 5, for the next 10 matches. And they're going to think about how many matches are going to be cancelled, will they be able to get 7 matches in? And what are the chances that we can actually get 7 out of the 10 matches played? For people who know their probability, it's actually a binomial distribution, but we won't mention that at year 7. We'll just play with the spreadsheets, we'll apply the algorithm, and we'll look at the results, and we'll see what comes out of that. In year 10, here's an example where students have to solve equations numerically using a spreadsheet. And they set that spreadsheet up using smaller and smaller increments to zoom or home in on a solution numerically. A similar activity might be, say, using the bisection method or the Newton's method in year 11 and 12, but this is using spreadsheets and graphing software to zoom in on a solution, with the extension looking at equations like, what have we got there, 2 to the x minus 7 equals 0, or where we have a polynomial equal to an exponential, where an algebraic technique is definitely not the way to go to solve that equation. So those activities are 1 per chapter, so there's 40 across the series. As I mentioned before, there was 30 odd references to the words First Nations, so this is something that we wish to address as well. There's 2 examples of the elaborations in the Australian Curriculum V9, mathematics curriculum. Now, Scott, we decided that we'd also address this by coming up with a number of activities, around 4 to 6 activities, I believe, per year level, and each of those activities to cover the content descriptors of the new Australian curriculum.
Yeah, and taking a look at the elaborations, we didn't think it was really appropriate to just sort of cover those by adding, a question or so to an exercise every now and again. That doesn't seem to be the intention of those elaborations. So the investigative style, where we could cover multiple related elaborations in a way that made sense, that covered multiple strands across the curriculum, we thought a more in-depth method for addressing that content would be the right way to go. And similarly with the way that this material is being carefully reviewed by experts. So that is the intention with this material.
True. Thank you. Okay. In terms of our new sections in the Cambridge Essential series, here's some key examples where we have a little bit more on ratios, which is stronger in the new Australian curriculum in Year 7. It's now clearer that ratios is to be covered in Year 7. Volume of triangular prisms, it's clear that has to be in Year 7, as well as all the things to do with circles and circumference and introduction to pi and so on. Year 8, the 3D coordinates content descriptor stands out. Year 9, some work on errors and more on sampling in statistics, and there's quite a lot in Year 10 with the networks, logarithmic scales, combinatorics, percentiles, and two-way tables in statistics. So these are the things that are leading to new sections in the Cambridge series and not just refinements of existing sections. There's an example of the section that we've written for Year 7, circles, pi, and circumference. Here's a few snips from our section in Year 8, three-dimensional coordinate systems. Looking at coordinate systems just in the first quadrant, and on the right-hand side looking at a point P as a 3D coordinate, x, y, z, but on the left-hand side looking at a coordinate system using blocks. And there's a photo of a car park there because I think there's a mention of the car park in one of the elaborations in the Australian curriculum. But you can imagine trying to describe a certain place in the car park, you might use perhaps a blocking system like what's on the left. So we do have a section on that in Year 8. Let's jump over to Year 10 because we have 4 new sections on networks. So introduction to networks, isomorphic and planar graphs, trails, paths and Eulerian circuits, and some shortest path problems to finish. And that's connected to our geometry chapter. Also in Year 10, the counting principles and factorial notation, the maths of arrangements and selections, and also applications in probability. So there are 4 new sections attached to the probability chapter there that I mentioned earlier. By the way, the networks is in the core and the combinatorics work is in the optional material. Now, one change we have made this time round in the Essential series, for those who are familiar with it, is that we have decided to join the 2 geometry chapters as one bigger geometry space unit in Year 7. That brings Year 7 back to 10 units of work, which may be easier for teachers to plan around and to work into their timetables for 1 year of work. The chapter order is retained. The Year 8 and 9 order is retained as it is. And in Year 10, there's a little bit of change. So obviously there is the optional content that needed to be provided, as we've mentioned. The old 10A content, much of it, of course, is still there. And that meant that some reordering was sensible. One example of reordering that was sensible was that the logarithmic scales, the extension with logarithms, and the exponential work has now come together as an exponential and logs chapter. There's some other reordering in Year 10 which made sense as well. It made sense for us to put all the extending or 10A material that's no longer in the new Australian curriculum, so it's not in the optional as well. A lot of the 10A material that we felt was popular and was used in many schools that wanted to create pathways to higher level maths has been retained right through the series. All this material has been retained. So an example of that is chapter 10, where polynomials, functions and graphs is chapter 10. It'll be digital only for the Australian curriculum, but all of that will be available as part of the series. Other example of retained material would be the measurement associated with cones, spheres and pyramids, which is no longer in the Australian curriculum, but retained in our series as extension. Sine rule, cosine rule, area of a triangle is still retained as extending material, among other units of work.
I guess, David, with not that much change coming to Queensland in terms of much deleted content from, say, methods and specialist, it would not necessarily be that wise to suddenly not teach a whole heap of, more extended algebraic techniques and graphing and focus on functions in Year 10 as preparation for those courses for students who are going in that direction. Hence, if we put this material in the book, it would be too heavy for Kim and Annie to put here, even using the trolley, but we certainly didn't delete it altogether, hence the digital-only chapter.
Correct. As I said before, we're retaining the structure of the exercises, but some work was done by the authors to refine the first and second question and how that links to the example, just to make sure that the accessibility of those early questions was there for weaker students and for those students who weren't doing a lot of work during the COVID period. So a little bit of an easier entry point in every exercise, and making sure that the examples, the first example, did not go too far with its parts in terms of its difficulty. So some work being done there. All the digital that you might be used to, like the worksheets that are available, the fixed tests, the quizzes, the digital quizzes, three per exercise, and all the videos, of course, are being updated to suit the new series and the new curriculum.
Dave, could I just request you go back one slide?
Sure.
With the start of every exercise, David has mentioned, I think, the links to the worked examples. The answer now to any question from a student about getting started on an exercise and putting up their hand about how to get started and how to do question 1, question 2, the answer to that question is really to point them towards the first worked example in the lesson. That is always the basis of the first question in the exercise every single time without exception.
Yeah.
The building understanding questions really are a testing of the ideas and definitions and basic concepts that are covered in the key ideas. And then when the exercise begins, really the pointer to how to start that, if a student is wondering how to get started, is always the first worked example in the lesson.
Correct. All right, so the videos and all the digital material is updated. One new feature which we're adding this series is a skill sheet, because many teachers gave us plenty of feedback saying that one thing they like to do is provide their students with an exit ticket at the end of a lesson, or something to do for homework that can be handed in, or something that could be used as a 5-minute, 10-minute quiz at the start of a lesson. And so a decision was made to write a skill sheet, 1 page, 2 sides, 1 page skill sheet that connects very strongly to the key ideas and the key examples in that section, a printable skill sheet. So it's a little bit old-fashioned, the skill sheet, but still very popular, and people did let us know that they would like this feature connected to each lesson of the series. So they have been written as well. So that's a new feature. Another feature is that every section will also be rearranged and put into a PowerPoint format. So for those teachers who do like using PowerPoint, or for those teachers who are taking a class, someone else's class perhaps, and they just want something that's easy to present, they will be able to present the key aspects of a lesson in a PowerPoint form, where the lesson starter might come up, the learning intentions will come up, the examples will be there, the now you try will be on the next click, and those with a tablet could write on the top of that as well if they wanted to show a solution. So a PowerPoint format for each lesson, all the introductory material in that lesson.
And there are certainly examples of teachers who wanted this, spending dozens and dozens and dozens of hours trying to create these themselves. So this will be provided this time.
Now that leads us into perhaps something even more exciting, and that is something we've been working on for a few years now, which is a comprehensive diagnostic tool that will be included as part of the package with the Essential series. We already have fixed tests that teachers can print off or alter. We have the test maker, but we wanted something slightly more comprehensive that links the skills of each section with the learning intentions and the success criteria, where teachers could come up with a test, a high quality test, covering all the sections that they choose, or covering all the Australian curriculum content descriptors that they choose, with a varying level of difficulty if they choose as well. So the diagnostic questions available will have a range of relatively simple questions, medium level questions, and challenging questions. And with this diagnostic tool, we have identified around about 250 skills per year level, and we have written this tool really based around those skills and how they connect with the examples in each section. So I'm now going to ask Scott to come up for the lectern and talk a little bit about the detail there of that. Thank you.
Thank you, David. As David mentioned, this is something that is new for this edition. This is something that Cambridge has not had before. So in terms of the motivation for putting this together now, it has been a lot of work. I was being sent many homemade versions of a diagnostic program from schools around the country, generally Excel-based, that had taken questions from the textbooks and tried to do diagnostic testing with those. So one of those, for example, had 16,000 920 cells for a single class. So manually entering data and running tests using Cambridge content was something that schools were already doing. So we thought that we could help out in a way with that. It was a gap in Cambridge's suite of resources, as mentioned. David said, you know, we have quizzes, we have a test maker, we have lots of other resources, but we didn't have a comprehensive system for doing diagnostic assessment. There are certain strengths that the Cambridge books are known for, and by linking them up together, some of those that David mentioned before, we could offer something unique. And finally, David had long service leave. We had a gap year, in a sense, for our 7 to 10 publishing a couple of years ago. That's something, I recently passed my 10th anniversary year at Cambridge. I think that is the first year where we hadn't been doing some form of 7 to 10 publishing. So there was an opportunity in that regard as well, because of the amount of work and question writing and everything that has gone into this. So you may be familiar with other systems, and you may have your own or be aware of issues with some ways of doing diagnostic assessment for maths. Students repeating content multiple times. That is being, there's some algorithm behind the scenes that is doing the testing for the teacher, and the teacher is not making those decisions. Students being misdiagnosed and assigned content automatically that is below their level. Students being prevented from progressing when they're clearly ready through other types of evidence. Not providing the student growth that has been promised. That is a common one. Too much of a black box, so the way that the thing works is hidden. There is a lack of clear structure for teaching the content. And finally, students expressing negative feelings about how they're being scored by the system. So those are things that we wanted to avoid with our system. So I put a set of principles together right at the beginning of this to help us guide us as we went through this. I just realised how much text there is per slide on these, so I won't read every single one, but the gist of it is to provide data that is aimed at evidence relating to both attainment and achievement. Attainment meaning what level a student is at as compared to accepted standards, and achievement meaning how they compare against their own previous performance. So the intention here is to provide teachers with the information that they could find useful at a time that is useful, with recommendations for next steps for how to improve student outcomes. And finally, the intention is always to show the data in useful graphical forms, and something I didn't put there is that the data can be exported in different ways so that a teacher in a school can do with the data what they may already be doing or want to do with it. Okay, so for students, we want to provide individualised feedback to students to help identify their strengths and areas for improvement, as well as provide indicators of performance in a way that is not demotivating, but particularly for lower ability students. Provide opportunities for self-reflection and the opportunity to take responsibility for their own learning, and finally for the administrator, some tools to compare data at a school level, to make sure that there is a consistency across year levels for how testing is done. So all of those are the guiding principles that have been behind this the last couple of years. Okay, David mentioned the idea of mathematical skills. So you can see in this diagram that this is something that is common to both the curriculum and to the textbook sections. So in the middle here, this diagram is illustrative. If you can imagine the curriculum descriptors broken down into the most detailed usable units of testing, that's sort of the thinking behind it. And it took a few goes, didn't it, David, to get that right, that level.
Yeah, one of the things that was quite useful was we tried to come up with a list of skills for a particular lesson or a unit of work, and then found that our examples would support that, but we might find that we didn't have an example that had a skill that we felt was important. So as we were writing this diagnostic tool over the last 3 years, we found that that really fed nicely into the textbook, and we wanted to make sure that the sections, the learning intentions and the success criteria with the skills really were very tightly connected, and they were very strongly linked, not just to the textbook but to the curriculum as well. And so with the fields that teachers can choose in the diagnostic tool means that they can really home in on the skills that they want to cover in that particular test.
Exactly. So whether you choose, and we'll talk about this in a second, you choose to run tests and build tests out of the structure of the textbook, or whether you go through the curriculum and you drill down in the necessary level of detail, the results will be shown against the same set of mathematical skills, any that are common to both. So regardless of the methodology, there will be data. If you choose the curriculum view, there will be data against the textbook lessons, and the opposite is true as well. Okay, this is probably a little bit more detail than is needed at this point, but these are some of the, this is the gist of how it works in terms of the steps of building tests and going to the next stages. So David mentioned the 4 mixtures of questions. So rather than just choosing a single, well, we have tried to make certain things easier. We've tried to give teachers a lot of control, but where we felt we could save time, we tried to do that, and one way of doing that was to choose 4 mixtures of difficulty levels. So there's a mixture of easy and medium questions, all medium, then a balanced mix, and then what's the last one? Mostly medium and some hard. So for every mathematical skill, there's 5 questions written, 2 easy, 2 medium, and 1 hard. So the idea of what is a diagnostic assessment question, what is the appropriate level of detail, how much problem solving should be involved is something that's up for debate. So regardless of what your feelings about that are, you'll be able to do the kinds of testing that you might want here. Okay, there's the ability to set a post-test. So in any particular sized unit of work, whether it's a whole chapter, half a chapter, whatever it is, whether you're a school who does a post-test and then a pre-test and then a post-test, or you do a pre-test and a mid-topic test and then a post-test, or you disagree with the idea of a pre-test in that sense and just do multiple sort of topic tests followed by a post-test. Any of those models is possible with this system, regardless of the size of the unit or how many tests per unit. And finally, there's the ability to measure growth and do a whole bunch of things using the reports. You'll see that this is for anyone who's familiar with the test maker and other features within the online teaching suite. This will be very familiar to you. We've talked about the question banks before. So one question bank contains all the questions that, if you're building your pre or mid topic tests, all the questions are taken from there, and they are paired with twin questions in the post test. So any testing that you're doing throughout a unit, you can automatically set a post-test that tests exactly the same content, but they aren't the same questions. So students won't be able to memorise the answers. The post-test will be editable as well. So if it compiles too many questions, you can remove some as needed. I've mentioned some of these as well. There'll be a lot of support for this tool. There's a lot of detail. We have had it user tested. The user testing is still going forward. Some people in this room are involved with that, and we thank you for your participation in that, but there'll be a lot of support with how to use this system. So teachers are ultimately in control, and it may be overwhelming, say, if students were getting their results of their diagnostic tests directly, so that the teacher will be in control of filtering that material and sending information to the student. Okay, so there's a couple of main report types. Some of these are fairly predictable. One by question. You would be able to do the usual types of filters that you'd be familiar with in order to create a Goodman chart, say. And then reports by skill, which you can then zoom in and out in various levels of detail, say all the way up to a strand, for example, if you're looking at a curriculum view. There are other report types that are focused on growth, measuring the difference between any test and a post-test, looking at a list of mathematical skills in terms of performance over time. Then there's the one at the bottom is a way of plotting growth versus attainment so that it falls into a natural set of quadrants. You can see probably that the student in the top right-hand corner, it's a very small graph I know on the screen, but a student who is flying in terms of their attainment and their growth is doing really well. A student who is not doing so well in terms of their attainment and they're also not showing any growth is a student that might be really struggling. So this is the intention with some of these graphs. Okay, in terms of setting follow-up work, that is one of the big features that we wanted to prioritise with this. So just to take you through the thinking, the basis of the mathematical skills are the textbook worked examples. There's not a 100% correlation. Sometimes the worked examples they're a little bit too broad, so they're broken up occasionally. In the interactive textbook, all the worked examples have demonstration videos. All the worked examples, as David showed before, have now you try questions connected to them. You can sort of see where this is going. Incorrect test questions in the diagnostic system will show weaknesses at specific mathematical schools, and therefore all these things can be linked together. So weak performance against mathematical skills can lead students to the matching worked examples, the matching video of someone doing the question the student got wrong in their test. They can try identical type questions, and then they can be pointed towards exercise questions for additional work if that's something that you want to do. So the teacher is always in control. The recommendations are automatic, but the work itself and what the student sees is directed by the teacher. Okay, in summary, the questions, the thinking behind the metadata is created by the authors, so it has the same philosophy, the same pedagogical thinking, the same principles as the other content that David was talking about tonight. The teacher is always in control for the reasons mentioned already. This is a tool that comes with the online teaching suite, so this is not an additional subscription, it's not a paid for an additional add-on. Whatever teaching program that you already use, whether it's with Cambridge or not, an idea of how to teach the curriculum, if that's something that you think works, you'll be able to do that with this tool. We don't mandate that the diagnostic system has to be done in a particular order. And I mean, the textbooks, for all the reasons that David has mentioned, are still the primary resource for delivering the various courses to deliver version 9 of the curriculum. But we think that this is a tool that will help get the most out of those books.